Right, so we're going to finish up section 2.1 with a few more definitions. So our first definition that we're going to look at is going to be infinite and finite. So a set is said to be finite if it contains no elements or the number of elements of the set is a natural number. So basically we have a limited number of elements in our set. We either have the empty set or we might have 2 elements or 3 elements or something along those lines. A set that is not finite is said to be infinite. Right, for example, the set B equals 1, 2, 3, 4, 5 is finite because we can count that we have 5 elements inside that set, where the set of counting numbers, right, or natural numbers is infinite. It goes on forever. A couple other words that we want to look at. Set A is equal to set B, which we're going to be using an equal sign to show that our sets are equal. So equal means that our sets are exactly the same. Right? So set A is equal to set B, symbolized A equals B, if and only if set A and B contain exactly the same elements. In the next definition, the cardinal number of a set A, symbolized by n parentheses A, is the number of elements in the set A. So that n comes from the number of elements that is in our set. So again, this ties back to our idea of a finite set versus an infinite set. If we have a finite set, so for example, our set up here has 5 elements, we would say n parentheses B, because we're talking about set B, the number of elements in set B equals 5, because there's 5 numbers that are in there. Right. Another definition that we're going to look at is the word equivalent. Now, a lot of times equal and equivalent mean the same thing. That is not true when we're looking at sets. Notice that our symbols here are different than what we saw for equal. So equal means that what we have are exactly the same, where equivalent, what we're looking at now, means that our sets have the same cardinality. Right? So they have the same number of elements. 2 sets that are equivalent can be placed in 1-to-1 correspondence. And then one last definition here, a universal set symbolized by U is the set that contains all the elements for any specific discussion. And we're going to see this used in a lot of other questions as we start moving through the sections. So for example, if the universal set for a problem is defined as U equals the natural numbers from 1 to 10 that we see there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then only those 10 numbers may be used in that problem. So our universal set gives us kind of some boundaries for what numbers are being able to be used as we're going through and we're looking at these things. So again, some of these words we might be comfortable with. Just remember as we're looking at these definitions that equal and equivalent mean different things. And anytime we see the word cardinal number or cardinality, that is going to refer to the number of elements that we have in a set.